Okay, so I'm going to be talking through the calculus that we can do using the exponential function. We've already seen what the exponential function differentiates to, and the natural log function. So, taking as our starting point, y equals e to the x. We've already seen dy by dx is also e to the x. How does that change if you've got a more complicated function involving e? Well, we will need to recall the chain rule. Dy by dx is dy by du over du by dx. So, for example, if you had y is equal to e to the 2x, then we can treat 2x as the function u. And in order to work out dy by dx, I need to know what's dy by du. So I'm going to differentiate y as e to the u with respect to u, and obviously that's trivial. It's going to be e to the u still. And I need to know du by dx. So that starts here. And I differentiate u with respect to x. I get du by dx is equal to 2. So dy by dx is equal to e to the u from here times 2. Substituting u back in, that's 2 e to the 2x. Which makes sense when you think about what y was. If y was e to the 2x, you can see that dy by dx is equal to 2 e to the 2. Oops. Equal to 2 e to the 2x. And obviously that works for any value here. So if y was e to the 6x, that would just become, oops, dy by dx is equal to 6 e to the 6x. And in general, this expression here is the differential of the function in the power. That's how chain rule works. You differentiate the function, and in e to the x's case nothing happens, and then you multiply it by the differential of the function. So you can stick whatever function you like in there, x squared plus 6, and the same rule always applies. Dy by dx is, well, it's e, so that means it doesn't change, multiplied by whatever the function in the brackets differentiates to. And what does x squared plus 6 differentiate to? Differentiates to 2x. So that's 2x e to the x squared plus 6 by chain rule. Maybe also at this point, worth pointing out that we're going to end up using the product rule a lot with e's involved as well. Because in the past, if we'd had something like x squared plus 1 times x plus 3 cubed, we could have in theory have expanded that out some polynomial and differentiated that. And some of the examples we saw when we were doing product rule for the first time, we could have solved without without using it. People did. But now if I have an expression that's a product, like x squared e to the x, there's no option except to use product rule to differentiate that, because there's no way you can expand out x squared e to the x. So, just as a quick reminder, and you've got to stay in the habit of doing this, write down what u and v are, write down what du by dx and what dv by dx are, and then plug into the formula u dv by dx plus v du by dx is equal to dy by dx. So this is just serving as a reminder, really. U dv by dx, x squared e to the x. Let's go with green, plus v du by dx equals to x squared e to the x plus 2x e to the x. The nice thing about e to the x, because it differentiates to itself, is that products inevitably can be factorized. And if we had to differentiate it again, we'd only have to use one application of the product rule. So if I wanted to find d2y by dx squared, now that it's factorized, I can treat u as e to the x, which means du by dx is still e to the x, and I can treat v as x squared plus 2x, which means dv by dx would be 2x plus 2. And you can just drop them into the formula of u dv by dx e to the x times 2x plus 2 plus v du by dx e to the x times x squared plus 2x. And then once again, if you were going to do anything simpler, anything further with that, I would factorize it to take the e to the x out. X squared plus a 2x from there and a 2x from there is 4x plus 2. And so on. As long for as many times you want to differentiate it as you like. So that's e to the x. What about natural log? There's two ways I've seen to prove what natural log differentiates to. I'm going to show you my preferred one. There's a slightly different one in the book. So let's say y equals log x. Now log, remember, is just ln is just log base e. ln is log base e. So that means I can rewrite that expression as e to the y equals x. That's the definition of what log is. So I might not be able to differentiate this expression at the start, but this one I can. So it won't be dy by dx, obviously, because now x is the subject and y is the variable. So I'm going to get dx by dy. What's dx by dy? Well, it's e to the y, because e differentiates to itself. That's no use to us, really. We don't want dx by dy, we want dy by dx. We started with this function. So if e to the y is dx by dy, sort of a special case of the chain rule to say you can take reciprocals. But if dx by dy is e to the y, then dy by dx is 1 over that. Well, what is e to the y? We've already highlighted it there in green. E to the y is x. So 1 over e to the y is 1 over x. So that's the rule and the reason why log x differentiates to 1 over x. And again, follows the same sorts of product rule, chain rule as before, with one slightly interesting maybe slightly unexpected anomaly. So what does y equals log of 2x differentiate to? Well, let's treat it as a chain rule. Y equals log u, and u equals 2x. dy by dx we've just seen, sorry, dy by du we've just seen would be 1 over u, and du by dx would obviously be 2, which means dy by dx would be found by multiplying the two of those things together. 2 over u, or 2 over log 2x. No, that's not the one I was going to show you. That's easy, that's trivial. What about log of x squared? What happens then? Log of x squared, what does that differentiate to? By the same logic, it differentiates, and we can do this in our head really, but it differentiates to 1 over x squared. Did I get that right, the last one? No, that's not right, is it? That's why. Sorry. Imagine that I didn't say any of that. 2 over u. Here. Oops. 2 over u here. And what's u? It's 2 over 2x. Which means that it differentiates to 1 over x. i.e. both log of x and log of 2x differentiate to 1 over x. Why is that? Well, you can answer that yourself by thinking about using your log laws on log of 2x and seeing what it differentiates to. Similarly, for log of x squared, you can differentiate using chain rule. Dy is log of x squared, so dy by dx is 1 over x squared times 2x. Well, what's going to happen to that? It's you're just going to get 2 on the top, and the x's are going to cancel, so it's 2 over x. Again, you can explain why does log of x squared differentiate to 2 over x when log of x differentiates to 1 over x. And the reason for that, again, it can be found in your log laws. Okay, that should be enough information for you to be able to answer the questions. Best of luck.